Question number 3. A solution made from pure barium hydroxide contains 2.74 gram of salt in exactly 100 centimeter cube of water. The titration of 20 centimeter cube of this solution required 18.7 centimeter cube of hydrochloric acid solution to complete neutralization. Determine the concentration of hydrochloric acid. So, in here, you were given the mass of barium hydroxide, and it says that this mass is being diluted with exactly 100 centimeter cube of water. So from there, we can actually know the molarity. Okay, but how can we know the molarity when we don't know the number of moles? So the first thing first, you need to know what is barium hydroxide. What is the chemical formula for barium hydroxide? So barium hydroxide. Okay, so first you need to find the number of mole. Number of mole is equivalent to mass over RMM. So in your question, I've already given to you the list of atomic mass and the atomic number. So you are going to check on the atomic mass. So the mass here is the mass of the barium hydroxide, which is 2.74 given in the question. So 2.74, and then the RMM is barium, right? So the barium is 137.33, and then you have 2 OH, right? So you need to 2 times, so O is 15.9994 plus H is 1.0079. Okay, right. Then after you have done the calculation, you should get the number of mole for barium hydroxide should be 0.0159 mole. Okay, and then it states here that it will be dissolved in 100 centimeter cube of water. So molarity equivalent to mole over liter. So the number of mole is 0.0159 divided by 100 centimeter cube. So 100 divided by 1000. So you should get the molarity of barium hydroxide that you produce is 0.159 molar. Okay, now you already calculated the molarity of your sample, which is the barium hydroxide. And then, if you can see here, the titration of 20 centimeter cube of barium hydroxide, right? Although you have made 100 centimeter cube, but you only use 20 centimeter cube. So, molarity again equivalent to mole over liter, right? So the actual molarity that you already produced is 0.159. But you want to know what is the number of mole actually that you use in this particular reaction. In the question, it states here you only use 20 centimeter cube. So your volume should be 20 centimeter cube. You need to convert to liter. So the number of mole of barium hydroxide that you use is 3.18 times 10 to the power of negative 3. Okay, this is how much barium hydroxide that plays a role in your actual reaction in this particular question. So the next thing that you need to do is you need to write the balanced chemical equation. So barium hydroxide plus HCl, you should produce this one and this one. So BaCl2 plus H2O. Alright, why do I put 2 here? Right, so Ba and OH. You know that OH is always OH negative, right? So since OH is OH negative, but the formula for barium hydroxide is OH2, so means that you need 2 molecules of OH here. Then you can predict your barium is actually 2 positive, right? Since this barium is Ba2 positive, chlorine, you should know chlorine is Cl minus. That's why to make it balanced, you need to have 2 Cl over here, right? So since you have BaCl here, means that the rest of this thing is not balanced already, because you have only 1 Cl at the reactant. So definitely you need to put 2 over here. So once you put 2, you have 2 hydrogen here, and here you have another 2, so you have 4 hydrogen. So here you only have 2, therefore you need to add another 2 over here. So this is your balance equation. Okay, I'm going to recap again the equation. So barium hydroxide, so you react with 2 HCl, you will produce BaCl2 plus 2H2O. Right. So from here you can see that for 1 mole of barium hydroxide, you will react with 2 mole of HCl. Alright. So from the calculation before, you only use 20 centimeter cube. So that centimeter cube is equivalent to 3.18 times 10 to the power of negative 3 mole of barium hydroxide. So how much HCl that you need is 2 times 3.18 times 10 to the power of negative 3. Saying that you should have 6.36 times 10 to the power of negative 3. This is the number of mole of HCl. Alright, if you look back at the question, it states here that this combination of chemicals is until complete neutralization process. So it means that this is exactly how much HCl that you have and that you have used in this particular reaction. So since you have the number of moles, so you can get the molarity. Molarity equivalent to mole over liter. And then check again in the question, states here that it required 18.7 centimeter cube of hydrochloric acid. So you already know the number of mole is equivalent to 6.36 times 10 to the power of negative 3. And then in the question is 18.7 centimeter cube divided by 1000 to make it liter. So you should get the molarity of HCl that you use in this particular reaction is equivalent to 0.3401 molar of HCl. So this is your final answer for the third question.